And on page 431, you have this formula as a new formula. And it's a new formula that gets used when you want to see what your future value is going to be if you are making investments at a regular interval. So this would be like, okay, you get a job and you decide, I'm going to save $200 a month so I can go on a big trip. How long would you have to save that amount if you got a certain amount of interest? What would it look like in the future? And again, they will give you the formula, or I will give you the formula and explain what each things are as we're going. And we're going to do some examples with them, and this will be some fascinating math today. So you would be given the following formula. You wouldn't have to remember this formula because it is not an easy one to remember. And in this formula, they would tell you that R is the amount of your monthly investments, N is the number of investments, I is your interest rate per compounding period. So I is technically your rate as a decimal divided by the number of compounding periods. And it's asking to determine how many investments, or to solve for N, how long will it take to get to $100,000, right? Because you're wanting to buy a really nice car for $100,000, right? Oh yeah. So you want to buy a really nice car, and you can afford to put $200 a month. Like, how long is this going to take you before you can buy this car? So when we plug in everything into this question, the interest rate is 6%. We changed that to decimal. Compounded monthly. So then the I part of this question is 0.06 divided by 12. And what makes this formula a little bit more complicated is just the extra numbers that we have. But the idea is going to be very similar to the equations we were using the other day. We are going to start by trying to get our power by itself. And these will always be calculator questions, so we just now need to do the mathematics to get that stuff that's in the green box all by itself on one side of the equation. So when I look at the equation, I notice, first of all, well, I'm dividing by 0.06 divided by 12. So I can go on both sides and multiply by 0.06 divided by 12. That would simplify that. Go to my calculator, 100,000 times by 0.06 divided by 12, and this changes to 500 equals 200, square bracket, 1 plus 0.06 divided by 12, and minus 1, square bracket. And again, you might want to color code it as you're going to help remind yourself that's what I want to get by itself. What mathematically should I do next to get that by itself? Well, could I move the 200? Could I move the minus 1? What's my order of operations? Right? Next, you could move the 200 by dividing both sides. Order of operations says that 200 multiplying happens before this minus 1, so I have to deal with that first. So I'm going to now divide both sides by 200. That will give me 500 divided by 200, simplifies nicely to 5 over 2. I still have the 1 plus 0.06 to the square divided by 12 to the n minus 1. Can you see that I don't need those big square brackets anymore? They were holding that, but now you wouldn't need them. Again, I want to get this by itself. The only thing I have left to do is add 1 to both sides. Adding 1 to both sides will give me 7 over 2. And now I've finally got the power by itself. What we can do next is now start using our logarithms. So if I take the log of this side, as I'm solving for an exponent, I can move the n out in front and take the log of this side. Divide both sides by the log of 1 plus 0.06 divided by 12. Type this into my calculator, and you should test your calculator skills to see if you type it in correctly. $251.1 is what it is as a decimal. This is an interesting kind of question because the question was asking, right? We go back to the original question. Questions, how many would it take to make the future value 100,000? To the decimal place, it's 251.1, but you're not making 0.1 of an investment. As a statement here, it would take 251 is not enough. To make sure that you had 100,000 or more, you would need 252 investments. So sometimes the rounding in these questions is interesting because in this case, we're going to have to round up in order to get $100,000. 251 wouldn't be enough. And interestingly, if these were monthly investments, if I divide this number by 12, that's almost 21 years. So if you're only putting away $200 a month and you're hoping to buy a $100,000 car, it's going to take you a little bit of time. You will not get that $100,000 car right away. So what happens is if you wanted that $100,000 car, you would need to pay for it or get a loan, and then you'd be paying interest. And that's more typical of what happens in real life. Most of the time when you want to buy something expensive in real life, you do not have the money in your bank account to do that. It's pretty rare, especially early on. You're like, I want to buy a car. It's going to take me too long to save up. So instead, you get the bank or get the car dealership to give you the car, and you take out a loan, but then you have to pay interest on that loan. Okay, questions to circle are 3 and 6. And we're going to go to example number 2,